In this video, I will describe how to calculate the mean absolute deviation for a given set of data. So you can see again here we have the taste tester ratings of coffee A displayed in a dot plot. The mean of this data we could calculate to be 6. Down here I've written out each data point. So there's one rating of 2, 3 ratings of 3, and so on. We can add these all up and divide by 32, which is the number of data points we have in this list, and that gives us 6 for our mean. Now, to calculate the mean absolute deviation, it's the average distance each data point is from the mean. Remember that definition from the previous video? So, we need to first find the distance each data point is from the mean. So, how far is 2 from the mean of 6? Just looking at it, you're probably thinking 4. Okay, but what if maybe we're working with decimals or larger numbers and it's not quite as obvious to us? What calculation are we actually doing to get 4? You probably said 6 minus 2. You're exactly right. And so we just keep going. How far is 3 from 6? Again, it's fairly straightforward. We get 3 for each of those. 4, how far is 4 from 6? 2, right? 6 minus 4 gives me 2. 5 is only 1 away from 6, so each of these data points are 1 away from 6. How far is 6 from 6? A little bit of a strange question, but it's 0 units away. 7, how about 7? 7 is only 1 unit away from 6. If you're going to do a calculation, you'd probably take 7 minus 6. You get 1. Now, if you wondered where the word absolute comes in at, it happens to be right here. If you keep the same format of subtraction that we started with here, of the mean minus the point, the mean minus the data value, here you would actually get 6 minus 7, which is negative 1. We don't want that, so some formulas will use absolute value symbols. Don't get hung up on it. It's just how far is it from the mean. How far is 8 from 6? Well, 8 minus 6 is 2. That's 2 away. 9 is 3 away, and 10 is 4 away. Now, we now have the distance that each point is from the mean, but remember, we need to find the average distance each point is from the mean. So what are you going to do next? If you said, well, just find the average of all of these numbers, you would be correct. So all of these distances, if we total them up, we end up getting a number that I have written down over here. We get 52. So the total is 52. If we then have 32 data points, so 32 in the list, our MAD, our mean absolute deviation, is going to be 52 divided by 32, which is 1.6 if we round. So this tells me that the MAD for this set of data is 1.6. Let's try it again for ratings for coffee C. Before we do, my first question is, which MAD do you think will be larger? Do you think the mean absolute deviation will be larger for coffee A or coffee C? Let's take a look. I actually already did the calculations on this one. The mean for this set of data was 5.7. So how far is 0 from 5.7? It's 5.7. So I wrote it just once, but there's actually 4 5.7s here. Again, there's 3 4.7s and so on. And you can see the whole list here. Alright, so these are the distances from the mean. But I want the average distance from the mean absolute deviation. So I have to total those up, and those total the 98.8. Again, there's 32 items in the list, so the average is 98.8 divided by 32, which gives me a final mean absolute deviation. This average is misleading. This is the mean absolute deviation, which is the average of the distances from the mean. So the final mean absolute deviation is 3.1. And again, if we compare that to what we got up here, we can see that the mean absolute deviation is larger, meaning the data is more spread out for coffee C, which we can tell from the dot plots, but now we found a way to find it from one single number. And that's what statisticians are going to do. They're going to use the mean and a measure of variation, either MAD or standard deviation, to describe a data set. Essentially, any data set can be reduced to its mean and its mean absolute deviation, and that can tell us a pretty good story of what's going on with the data. Thanks for watching.